Hello, everyone. Today's topic is some serious topic about low-level system programmer that implementing the data structure based on Linux kernel linked list, right? But today's topic is not focused on the Linux kernel, right? More than focused on data structure implementation. So I prepared some content for the how we can implementing the Linux kernel-style linked list based on Linux kernel implementation. And I'm do this all about this on the user space, not the kernel space, right? So there's some bunch of things when we porting the Linux kernel implementation to the user space. So I will introduce that, and I will implementing the HashMap based on the kernel-based doubly linked list. And finally, I will implementing the LRU cache based on doubly linked list and HashMap. So I think this is some long travel, right? But I will pair coding with the implementation that this my GitHub repository. So take care about this, right? So let's go, right? So I will make new directory for the low level data structure, right? And hello. So in first, I will introduce Linux kernel linked list based on some abstraction, and so I focused the implementation for this. Right, first we need to implement the linked list list.h. So right, and I think you can see my stroke for this. Okay, let's go. The mouse pointer, right, and wait for it. Right. So I think you can see my keystroke now. Right, I need to general capture all keys, command keys only, all keys, right? Right. You can see here, it's so small, right? So I need to make some huge for this, right? Oh, great. Right. too huge, right? Right, great. So firstly, I will implement this based on the Linux kernel. So as you know, we need to some ifdef for the first time in the header file. So ifdef list h, right? Right. So and if list h, right? And we will use the macro, some built-in macro between in the GNU-C. So I need to add this GNU-C on the bar, right? Bar defined clan case, but I didn't use. I will not use sharing on this study, right? I will focus on some GCC usage for this prefetch. This is some optimization built in prefetch, right? There's no typo, right? Else, right? Do nothing if there's no built-in prefetch. So while 0, right? This is the start of the implementation, and there's some fascinating in the kernel implementation on the linked list. So you can see from the explanation from this comment, cast a member of a structure out to the containing structure, right? So first parameter ptr that indicates the pointer to the member, and second param type, the type of the container struct. This is embedded in, right? And prompt member, the name of the member within the struct. So I will define container of ptr, type, and member. So const type of type, right? And 0 number. And TTR, right? And type char pointer and PTR minus offset of type and number to close and this. So you can see the typo in here. Right, good. Good. Good for this. Right. Right. There's mistakes here. So right. You can see the container of implementation. So I will review for this implementation later in the example. So next is these are non-null pointers that will result in page fault under normal circumstances used to verify that nobody uses non-initialized list entries. Right. And we can define some risk poison. One as void pointer 0x0100100100, and another risk poison to choosing void 0x002002 0x00200200. Right. This is proposed for the non-initialized list entry, the debugging purpose, right? And finally, we met. Simple doubly linked list implementation. Some of the internal functions on the bottom of the bar xxx are useful when manipulating whole lists rather than single entries, as sometimes we already right know the next 12 entries, and we can generate better code by using them directly rather than using the generate single entry routines, right? And right, this is the command for the struct with head. Wow. And struct with head. Pointer next and prep. I think this is better to view, right? And semicolon, right? So we define the list head, the heart of the doubly linked list, right? So list head init name at name, right? Right. This is the list head init macro. So next list head name. They eat the name, right? Struct list head name and list head init name, right? And define init list head ptr do ptr next ptr prep ptr, right? Right, 0. Right. And like this. So we make some initialize for the list head in this macro. So you can see when the list the initialize, I think we can refer the real implementation when the using the linked list, double linked list in kernel-style with the this project list.c. So here init list head. So this is the some container that have the list head in their member, right? So someone show like some unfamiliar why the linked list are not the some pointer and real data in the Linux kernel. They are using something like this because this makes some usually other programmer using this data structure in other subsystems, other usage. So this makes some people make some common for their implementation, right? So you can think that the data structure and the member of the linked list are pointing other data structure, and they have the linked list member for the list head, right? So real data is this in A on the list, right? Value and some string, right? So you can see the B list and iter, right? So initialization for the B list like this, right? So we defined for the append for this real data structure, struct A underbar list in this function. So we can customize for this for our data structure A underbar list in here. So you can see this, right? We need to uh, input the string and value for on A underbar list data structure, right? So this is the some pointer that you can see in here. Be list some pointer for the our data structure, right? And ptr pointing the B list in main function when the append be called, and the tmp for the new entry for the A underbar list are dynamically allocated, and we input the value for this, right? So entries are taken, and for the adding the real list for the some chain made by this list on the add on the tail, right? So I said this is the doubly linked list, right? Doubly linked list. So as you know, there in the list implementation, there should be tail and head, right? But the doubly linked list, as you know, they are circular shaped, right? So list on the add tail will add entry to the this B list, right? So we can add a string for this and some value for this, right? And list for each entry, this will utilize the linked list head, this member. So we can iterate by this list member. So this list for each entry will iterate for the B list. Right. So print this, and we can make some free for the each entry. So when the list entry will be empty, they are iterate, right? So iter take the list entry, right? And entry will be deleted, right? And freed the entry. and this continues until the list goes to empty, right? This is the real example for the linked list implementation, right? So, oh, but there is a bunch of questions. Thank you. Unrelated question: how do you install build Linux kernel on Mac OS? Ah, right. Actually, this is not the native environment. Mm. I will connect to the machine in my ARM board with the SSH, right? Right. So this is not the some match this topic for this time, but I need to some powerful board, right? So this is some rest time, right? I'm not a endorser or influencer for this board, but I think this is some share for uh, good things, right? There is some powerful board for the uh, ARM ARM architecture machine, so I buy this, right? So this is come from China. Price is very good, right? Uh, comparison to Mac or other board, I need to install the native environment for the large RAM size, right? So I buy this, and there is no commercial board for the consumer, not the some server vendor. This 9.2, right? Yeah, you can create a beat on using this setup, right? Thank you, right? Uh, I have some troubleshooting when install the Ubuntu for this board, but I made it and I very happily use this time, right? So, right, powerful. How do you install load OS on a motherboard? I'm curious. Right. Actually, they have some documentation for the install Linux, but uh, there I experienced very nervous because they not support virtual machine on the board in the this documentation. Very um, low version of, right, old version of Debian, right? So Debian kernel not support the virtual machine, but when I install the 2.5.10 Ubuntu on this board, it worked well, right? So I buy these things, right? I didn't buy this, right? So I think heatsink is very important for this board. They are very hot, right? Hot board, right? So in this time, I'm utilize the whole power of CPU for the fuzzing. But as you can see, this works well. Good, right? So I need to buy the powerful ARM board, right? So and there is some question for other. What use for str for string type content, right? Right. Mm, you can um, uh, you can modify this code You can see this code in here, right? With the make list. So you can see the real learning for this example, right? Yeah. And UI 뭐 hello 안녕하세요. 네 안녕하세요. 네, 저 한국 사람입니다. I am Korean. Yeah. Do double linked list need to be circular, right? So I need think about that, right? But some picture that I've seen in most case for the implementing doubly linked list in the Linux kernel are they make some pictures, some circular, right? Did you try? Right, I'm big fan of Raspberry Pi, right? But as you can see, I can compare the power of the Raspberry Pi with this board, right? And Raspberry Pi are not the ARM V9.2, right? So you can see I have the a bunch of Raspberry Pi, right? Uh, I am experienced with a bunch of Raspberry Pi with the Kubernetes environment with myself for the some research, right? So Raspberry Pi 5 are good, right? This is good board, right? I think this is great board, right? 16 gigabyte RAM, right? And powerful 876 core, 4 core, right? 4. So, but as you can see, this have a 12 core, right? So I'm running the virtual machine for 3 allocated with 3 CPU and 4 machine in this time, right? And right, 2.4 gigahertz, 2.6, and actually this is the important part, right? And that I didn't learn the run the AI in this machine. So, but right, as you can see, huge memory, right? There's option for these things, but I buy these things, 64 gigabyte. For starting, I think Pi go to board, right? Right, great, right, great support and um, very reliable board, right? And powerful, right? Not much for this board, but uh, if you make some break for this board and didn't work well, or you can split the water on this board, you can very you can mind harmful, right? But this board is affordable, right? And right, you can save the uh, some pizza uh, to 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 time, right? You can buy this, but this board, I think about $800, right? $700 in my memory, right? Right, right. The, and video power is good, right? I didn't use for the video, but right. So you can run these things, and I think you can utilize some uh, corner module for these things, right? right? So if you want to contributing to the media for the Linux corner, I think this is beautiful. It's nice to have a powerful motherboard. It used to take so much time sometimes to build corner. Right, right. I saw that benchmark for this board, so this board almost power for the Apple M1. I didn't in this page I can see, but I saw it. Right. A Raspberry Pi have less powerful comparison to this board. As you can see, there's a big gap, right? So I use this. Wish you the best. I will drop. Right. Thank you. Right. So I can go again for list of implementation. Right. So I think it's great for the question for about some Linux environment. Right. Uh, I have some experience in the server environment and in embedded environment, right? So it is good to talk with the Linuxer, right? Always funny, right? I always fun, right? My friend told me the uh, you you careful when you're using funny, right? Right. So I continue to implementing this header. Right. We can end up some macro implementation for this now. Right. So we make internal of the list entry add. Right. So oops. Right. So we can go insert a new entry between two known consecutive entries. This is only for internal list manipulation, where we know the next entries are ready. So static inline void unboundable list add struct list add. I'm familiar with this, right? And I think we can make synchronize indent add prep and struct list add pointer next. So in this implementation, we can imagine some entries here and prep, right? And you, this is the next, right? And this is the prep, right? Add in here, right? Right. So new prep is new here, right? Mm-hmm. And new news next is news next, right? News next is here, right? But right, next, right. So news next is here. So new in the view of the next, previous here, right? New things, and previous, old previous things, and new are here, pointing the next, right? And new prep, right? Previous, some new entries, prep, so old prep, right? So right, this typo, prep, right? And prep next is new, right? Prep next is new, right? So they are linked with the new, right? And right, if you have a question, feel free to ask me, right? I think this is the hard, not the easy. A new entry to be added had list had to add it before, right? So insert a new entry before the specified head. This is useful for implementing queue, right? I think queue implementation are not this topic because we can use easily with the list implementation with the queue for common case, not the specific case. So I don't add this queue implementation for this day. This is hard, right? Other HashMap or LRU Cache implementation with the list, right? Almost some low level, right? So I made this topic for today at tail, right? Struct list head, new struct list head, right? And right, we finally call the new, right? New is here, right? Hey, new is here, right? This is the wrapper for the list head for the such case on the add tail, right? So some folks, right, tell me about the circular list will be special case of the doubly linked list, right? So right, in this case, as you can see, this list have a head, right? List have always head and tail. Prep head, right? So this seems like circular, right? Head and tail is here, right? So head is previous tail for this implementation. So head is prep and head, right? There's new, right? So I think this makes some very fast when the adding the tail, right? With the not the doubly linked list are not connected with some circular things, they will need to for loop end of the right. I think iteration is more good for this case. Iterate for end of the list, right? With the in the head and tail is here. They search, not search. They go to end, right, for the tail. But when the circular and tail and head in here, you can go head prep, right? This is the tail, right? Very fast, right? So we implementing the list at the head tail, right? Cool. And select a list entry by making the prep next entries point to each other. This is only for internal list manipulation, where we know the prep next entry trees already, right? Static inline void on the list del struct list head star prep struct list head next, right? So this is the internal implementation for the list del selecting a list entry, right? So next prep, right? So as you can see, they will affect this next, right? And prep next, right? So this is the next, and this is the prep. Next prep, right? Next prep, right? Next prep will be prep, right? So I need to think about it. Prep next previous, right? Previous prep, right? And previous next is next. Right. Next is prep. Right. Next is previous prep. Previous next. Previous next is next. I need to think. I need to more think about it, right? This time. So, because there's some weird wrapper for this case. So, list there. Select entry from list, right? Entry the element to select from the list, not list empty on entry does not return true after this. The entry is in an undefined state. entry is an undefined state, right? So read carefully. So static inline void listed struct list head entry list the entry prep entry next and entry next list poison entry prep list poison 2, right? So right, actually this is the common implementation in the internal, right? So this is a real example for the selecting the entry. What the entry is? So this will the first parameter for the unabundant list there, right? And this is the second parameter for the unabundant list there, right? So select entry, right? Entry from the list, right? So this entry, as you can see, they are make some meaningless in here, and the input for this entries in here and entries prep is in here and entries next is here, right? So this entry and next is the prep and next right, next prep will be prep, right? This and prep next firstly pointing the entry will be next, right? This they are changing the pointer for this, right? Next prep will pointing the prep for this entry, right? And prep next pointing this will be change it and pointing this next, right? And the entry in this line, right? This next are some meaning will be changed value for the meaningless and prep also meaningless, right? So as you can see, you can understand what the note mean, right? Undefined state for this. So right, we saw the implementation for the list select. So list the init select entry from list and reinitialize it entry the element to delete from the list, right? So we can see the implementation for list del in it struct list add entry, right? So list del entry prep entry the next, right? this also call the list there. Previous we saw this, right? Entry, right? Okay. So init list had entry, right? Reinitialize entry, right? Move from the list the entry and reinitialize it from here, right? And next is list move. Select from one list and add as another, right? I think this overlapped, right? We going down and down, right? I think we can change it. Okay, where is the on the side might take longer time, right? I think I didn't know the moving the position, so I blur more blur, right? No, didn't work. Fine, right? Right. I need to make some tiny for this typing screen, right? I list move again. Select from one list and add as another's head, right? So list the entry to move, add the head that will precede our entry. Static inline void list move struct list head list struct list head list deal list prep list next, right? As you can see, right, this is me here, right? But the right, this is very fun, right? Something like some change the list, right? Wow, great, right? This is some new vision when the pair coding with the kernel implementation, right? So there's right, there's some list move for the entry are changed for the another list, right? And list move tail, right? Select from one list and add as another tail. At least the entry to move the head that will follow our entry. Right. I think we can offer this. Right. Static inline void list move tail struct list head star list and struct list head right. I think when we face the underbar tail in the Linux kernel implementation in the list, you can always see the head, right? Head is prep of the right. Head prep is the tail, right? Tail's next is head in the linked list implementation on the Linux kernel, right? Right. We are now pair coding the Linux kernel implementation, the linked list, right? No, but this code will be run the user space. We copy and paste the Linux kernel code in the user space didn't work, right? There's some tricky implementation for that using another subsystem's function and feature in the Linux kernel linked list implementation, right? So there, my pair coding with this code is some update the some code and right this will be run in the user space. So list prep list next, right? This seems like almost same, but the list and the tail is different. Right. As you can see, this entry, right? This select from one list and add as another tail, right? So, right. You can see that this list is one and another, right? Another tail, right? Right. Also, this another, right? But this will be added on the head, right? This will be tail, right? So very, very exciting. List empty. Test whether a list is empty. Add the list to test. Right. So almost case list empty will be using the some branch condition is empty, right? So return head next head, right? And there is some advanced feature, right? Splice. Right. I think we can skip this right? There's some bunch of things in here, right? In this course, we didn't use some splice, but this is the advanced feature, right? So, but fun, right? I going to pair coding this list splice, right? Struct list head. Oh, sorry, head head, right? And list head first list next and struct list head last list prep. Is there comment? No, right? I think some for each macro will be skipped in this uh, my session, right? Session or streaming, right? Right. I'm did not familiar with the streaming yet, not yet, right? I have some. Sometimes I have some streaming, but I have more session about in real offline, right? So at first last add, right? You can see this complex situation in here, right? But we need to keep on this first and last add. What does it mean, right? I think some variable name and this code makes them annoying my head, right? We need to some we need to see the wrapper for the LRU case on the bundle list splice, right? We don't know about the what the real argument in here, right? So I review this code after the our meet with the wrapper, right? Prep last last is next at prep is last, right? And list splice join to list list the new list to add the place to add it in the first list. Static align void. Actually, this time, what I want to get is some communication with the some people, folks, right? And some typing skill when I writing a code, right? This streaming makes them focusing on what I'm doing, right? I think this is great for concentration, right? So list kind of love this style, right? We need add the space, right? Always, right? This is the convention for the Linux kernel implementation, right? Right. Okay. So list empty, right? List empty, list splice will be added in the if case for the list splice wrapper. List head, right? So join to list, right? The new list to add, the place to add it in the first list, right? So I think this is the important point for what is the place, right? Add it in the first list, right? So this something like some container and have a member for the list, and container list are linked pointing like this, right? And list to add, right? So we can directing the point, what the point the adding, right? First argument is list, right? Like this list, right? And we can put this the target place to edit first list, right? So we can review the splice code, right? So I think this is the very important, the place to add in the first list, right? Head, right? This have important meaning in here. So list head first, right? List next, yeah, right? And last the list prep, right? Right? And add is the head is next, right? Head is next, right? So tail is here, head in here, and head is next, right? Add pointing the head is next in this scenario. Head means the place to add it in the first list, right? The first argument will add to the target head, right? So first prep will be head, right? I think this is some keep the position for the next, right? Head is next. So I think this is very similar to the list on the add in the previous, right? First prep, ahead, right? Head, right? First in here, and head next, first, right? Here, and last is next, right? Last is the list prep, right? So new some new list next would be some things like this, right? And the last next, right? Last is the some some list is next, and last is next, right? This is the new list to add prep, right? So last is next will be add, right? Who, right? We keep the target headers the next, right? So last next will be add, right? And add preview will be last, right? This seems like first list is next, right? This list is the new list to add, right? So list is next will be added in the next of the pad, right? And originally head are pointing the there's next, but the next this original next will be pointing from the lastest next, right? And at previous will be connected to the last, right? So I think I need more think about this, but these lists are connecting to the head of the target and previous next, right? So they put this on in here, right? So I think this is some picture of this function, right? I think some run from the example is more great to understand what this will be learned, right? Will be learned, right? Our pronunciation is very important, right? In in Korea, L and R is almost the same. we pronunciate like some L, right? So I need to I need to make sense, right? Right. So this is the list on the bus splice. Woo! Hard, right? List splice the init join to list and reinitialize the empty list. List the new list to add. Head the place to add it in the first list, right? The list at first argument list is initialized. Good. Static inline void list splice init struct list head star list struct list head if not list empty list, right? Almost the same for the previous list on the splice implementation, right? So on the splice list head but there will be list initialized again, right? Case is important, uppercase, right, for the macro. Right, so list the entry, get the struct for this entry, right? And ptr the struct list head pointer the type of the struct. This is embedded in member. The name of the list struct within the struct. Right. So macro again, right? List entry, ptr, type, and member. So this is important, right? We can see the use case of the container hop. Container hop is famous in the Linux kernel, right? It's especially when we are using the list in the Linux kernel, right? Get a struct for this entry, right? So the struct, the data container, have the member list head, so we can extract for the some struct for this container op, and we can samely, right, with a list entry for this case, right? I think this makes them easily showing the code when we write the code with the list implementation. So, but they are same, right? As you can see. And list for, right, this is important iterator for each. We saw this iterate over a list on this C implementation previous, right? Pause, write the struct listed to use as a loop counter. Head, the head for your list. So define list for each pause head, and this will be impressive because head, next, pause, not the head, right? Head, we can iterate from head to the tail. So tail next is the head, right? So we iterate all the time, right? So we can end the condition for this. And as you can see, right? And pause next, right? Or again, end of the link, doubly linked list. Circular doubly linked list is the more makes sense in this case, right? Right. So we can iterate the list with this, and right. There is other macro for this. But I think this thing, right. We don't need to add this, right? For each prep and for each save, right? I think this is the famous function when iterating the links corner linked list for each save, right? Pause, and I changed the some writing code, writing first and writing comments, right? For pause, head, next, and pause, next, pause, not, head, right? Almost same, right? Typo is here, right? I fix it. Right. And but the some impressive point is here. Pause and n pause next, right? So as you can see, there is some other point. N is added, right? So we keep the next for the n, right? And pause will take the n's next, right? So there is some explanation for this on the comment section. A list for each save. Iterate over a list save against removal of list entry. At pause, the struct list head to use as a loop counter, right? Loop counter, right? This is important, right? There's no n in upper implementation in the list for each. The head for your list, and remember the name of the list struct within the struct, right? Right. I think there's other implementation for the reverse iteration. And list for each entry, right? So we can review this implementation after the writing a real code for using this case, right? So I will make some code for utilizing this, right? Clear list.c. I think no header in here, right? So I need to add some header for this. Include stdef.h, right? There's some macro in here for prefetch, built-in prefetch or other things, and right, we need to print our code, right? Right. So stdlib.h list.h for this, right? I will add struct a list struct list head list, right? This is the some list member for the sequence of the A list, right? This is the some, how do I say, right? Making some connection for the whole the bunch of the A list, right? And int bar, right? Value and const star for str, right? Static void append, right? This is the real append for this struct, right? Right. We will use the list API inner function of this append, right? ptr monster pointer, right? Pointer str and int, right? I think we can change it back some order, right? Right. And struct a list tmp, right? We need to make some new entry. I think tmp is more better to using the new, right? So new need to typecasting struct a list and the list star, right? And size of a on the list, right? And if tmp error, right? Fair the h1, not the tmp, right? Change this. So new str new bar, right? I need to change the order. New bar, right? And we need to add list, add tail, right? New entry will be added in the tail of this bunch of list, right? So as you remember, had this previous tail on this implementation, right? So new list, right? And ptr list, right? Right, we implemented these things and we need to making a underbar list, b list, right? A list for the iterator, right? We append some string and value for each entry, and we will print these things, and we will uh, select and clean the whole bunch of the list, right? So we need to initialize our circular doubly linked list implementation, right? For the big list. So init list head b list that list, right? We initialize this and append some item, right? Entry, right? Both are good, right? B list. I think what is the good for this? I think go, right? There is no convention for this, so one. Right. I don't want space in here, right? Append build list, right? Meta, right? I love some test strength, so right. All right. So 0, right? And iterate list, right? Don't need to comment, right? We can see easily. Entry iter build list that list and list, right? So printf all of things. Str, right? Iters str. I think all is good, but right, we need to change this, right? Right there. So I think pointer, right? This doesn't matter in this, so there's no padding, right? So, but the first implementation code would be good for the looking good. So some string in here, right? But I I updated for this case, so we can see there is 4-inch entry in here, and we made a clean for y. Not list empty. It be list the list, right? And iter list entry be list the next, and struct a underbar list and list, right? Right. So we can get the entry pointer from this list on the entry, right? Next, instruct a list, right? It's the type of the bill list they contain, and right, list in here because the member of the list names are list for the a on the list struct. Right, so we can select the entry at iter list for this and free the iter, right? So you can find some matching for this malloc for the add for the this case and free the iter, but we need to remove from the list that entry. So first we remove the entry from the list, and we can free the iter, right? So this makes some safe to the UAF, use after free, right? And right, we can add this return value, and I think there's no error on this code, but I think if there some error occurs, I think there would be some typo on the code, right? Right. Oh, right. I have some typo. So 40. What is this? Right. I think this is my case, and I think don't need to these things. I think if there's some error in the header. Ah, right. Struct. Struct. right? And other, right? This is the list, right? Okay. And what is the error? Struct list has incomplete type list head, right? Stop H list head, right? Right, good. Right, seems like good. I think this is the good. So right. List head, struct list head, int bar, and append. Ah, right. List for each entry. 감사합니다. 고코이. Thank you. Have a good night. Right. What is the fault for the implementation? Four. Right. Good. I think this have no error for this point, right? And right, this also good. Container of recently, right? What is the problem? Again, I need to see that. Right. List field list has incomplete, right? The function listed. Alright. I think these code are not include the header of this, right? The list.head, right? All the error are arise from the not included header, right? So I need to find this. List.h, right? What is the missing for this? and if, right? Good. Curious about that. Why you not include this? I need to find it. What is the cause for this? So right. So restart H, right? No. Restart C. Can I fix this? Something like this. No. I don't understand why you didn't see. If not def, define, and if right, there's typo. Right. So right, we can see the many type for this, right? So entry prep, right? Okay, I make fixing them all. In the line of 103, there is entry prep. I make some minus for this. Save. And 1 to 1, there is list add, right? But list add, list there. Good. Right. List add. Okay, list add. Right. Another one, the list add. But there's no implementation for this. Right? Right, okay. So list add. Right. I didn't add this function. Why? Right. I think I skipped this. Right. I need to add them. List underbar add. add a new entry, new entry to be added, head, list head to add it after, right? Insert a new entry after the specified head. This is good for implementing text, right? Static inline void listed struct list star new struct list head head. And from the list add new head head next, right? Right. So previously I skipped them. So this function add the entry into the head, right? But this function add the new entry to the tail, right? So there is some explanation on the comment. When the head are added, right? And we can see some circular doubly linked list like this, head and tail and here. So head are stacked, right? Stacked, and so we can remove from this head, right? Head, right? Something like some dishes, right? Add some dishes, and we can clean the dishes in direction, right? So there is some comment for the queue. So some when the entries are added in the tails, we can see the tail and head and tail are growing, right? Tail are growing, something like this. Edit, right? We can consume this for indirection, right? So you can utilize anyway, but this comment guided some data structure with these stacks and queues. Add tail with matching the queues and list add in the head of the list are matching with the stack implementation. So we can reference this function, right? We review the source code for fixing our bug in our in my code, right? Right. So expecting printf, I think list for each entry, right? Right. Right. We wrote a code list for each only, right? I didn't write the code list for each entry, right? I need to check up about this, right? So I will add this list for each entry, iterate over list of given type. Pause the type star to use as a loop counter head, the head for your list member, the name of the list struct within the struct. Right? List for each entry. Pos head member for pos list entry head next type of pos member, right? Can add this the end of line and add pos member not head, right? Pos list entry pos member, the next type of pos member, right? So right, there's typo in here, right? So we can iterate it over list for given type, right? Previously, we saw the list member on our example list.c, right? And head. So this have some first entry for head next, right? And this makes some the member post member is not head, right? The container of this struct have a list as a member, and these are sequence for the some shape of the circular. And when we meet the head for this for loop, it will be ended, right? And post list entry will be changed from this, right? After the members next, right? So we can, oh, this another warning for this, right? Struct inside the parameter. All right. I have typo in this. No. In here, I need to compile again. Right. Where is the struct? All right. It doesn't make sense. Right. 76. Right. I'm making typo head. Right. And any other? Right. Hide. Right. Head. Right. And again, error expected identifier or right. Right, haha, totally missing this part. Right. Static inline void list empty construct list head star head. Right. Another problem. Return with a value in function. Ah, right. I think there's some typo, right? We need int. Right. Clear. Right. And right. I think there must be typo. List for each entry. Post head member. Post list entry head. Right. Oh. Right. Good. Mm-hmm. And next, type of start post member and post member not head and post list entry, right? Member next, type of start post member. Okay. Ah, right. There's typo, right? This is the 4, right? Only 4 with the semicolon, right? Oh, main printf. What is the problem for this, right? I think maybe this is not harmful because this is a 4, right? So we can add without some bracket for this. Ah, I made mistakes, right? Right. This is the end of the block for the for loop, right? Oh, VIM is very good. They make sense, right? This merge line, some bracket in here, right? Good, right? So in the code, we can see the list.c, right? In here, right? Append and we loop from the head to the tail. So this add append on the right tail and right tail, right. So for each entry, right, tail are add. So first entry will be a go, right? Right, add tail, right. So last element that added from the tail is testament, right? So this makes some in perspective of the head, this had this next will be a Google, right? And after the Google, the entry is meta and transparent, right? This makes sense, right? From add on Google's meta transparent in perspective of the head, Google is the first thing, right? Great. So we saw the list implementation, right? I think you missed the closing parentheses of the line, right? Good catch, right? Clear, right? Um, right. Mm, actually, I prepared this session for the low-level system software programmer because uh, there is lack of some implementing from the very low level. But the kernel programmer who did not accept this opinion, right? But because there's some assembly implementation in the Linux kernel, right? But I think when we faced something like some low-level system programmer interview, it, they say this is the low-level implementation. So I heard and I got some review for the interview. I saw that they are want to implementing the data structure, what they want, right? Most of the algorithm in the Linux kernel follow from the data structure, optimize data structure. Like this does not match some C++ STL. Uh, most of the user space framework implemented from the some layer of the framework from the STL in C++, but in the C program, we when we want to make some real great algorithm, we need to define the data structure. So most of the company want to accepting a new member. They they make some challenging for the writing a data structure for what they want. So I prepared today for the implementing the kernel-style doubly linked list, and this makes some chance to implementing HashMap or LRU Cache, right? So I will, I we ended this chapter. Build and test Linux kernel-style linked list in the user space, right? With the nested list head member, right? And we saw some implementation. So I think we just 2 hours of the Linux kernel style linked double circular double linked list implementation, right? Very interesting, right? So I think we need to um, make some next step for this two part, right? Right. I think HashMap implementations are very wrong, right? I guess, right? I make some code for this, right? Right. About I think shorter it would be shorter than the circular double linked list, right? And but right, I need to add some HList implementation on our list.h, right? So I will uh, I can add this. Mm, oh, four forks, right? Right. So I can uh, handle it with some time, right? So I'm cheering up again, right? Actually, I ended my today's streaming, but there's four people, right? Right. Oh, three people, right? But nevertheless, uh, I will implementing the HashMap on today, right? LRU is hard to implementing today, right? But I cheering up myself. So right again, go to the list.h, right? We need to add hash implementation. Double linked list with a single pointer list head. Mostly useful for hash tables where the two pointer list head is 2. Oh no, 2 wasteful, right? You lose the ability to access the tail in O1. So this meaning two pointer that the next prep for each element are wasteful for the some in direction, right? Direction, right? Direction implementation. So right, they need to define this struct each list node first, right? And struct each list node struct each list node for next. And the, the fun point for this, right? Pip prep, right? As you can see, list head have a next end prep, right? But each list head only first, right? So each entry have one pointer. But the how do I say the manager for this bunch of H list head is the H list on the node, right? These only have two pointer, right? This is the important point for the implementation for this. So we can define H list head init. The first with the null and define H list head name struct HList head name dot first define init HList head ptr first corner define init HList node ptr next the ptr right pprep corner right. So static inline int right HList unhashed right HList unhashed const struct HList underbar node with h right return that h prep right. I will review this code after the example for the HashMap, right? So you can follow up with some flow of the code implementation. HList empty const struct HList head star head right return h first right static inline int right no int void HList del struct HList node pointer n struct HList node and star n right no next right no next right n next struct HList the node prep n prep right prep next if next prep right and static line void HList del struct HList the node pointer n HList del n next list poison prep list poison 2 right as you can see this have the input HList node n right so this HList node have next and pp prep, right? And head have a right. I wrong explanation for the first time, right? Head is the manager, right? Head have a H list node, right? And node, right? Node have a link for the each H list node entry, right? So they check with the H list empty with the head, right? So head are first up exist. This is right. Head first, right? Exist makes some right first, right? So if head first are null, right? When the first time this is null, so this is empty, right? When the H list there select from this time, this makes some next. Keep the next for the entries next, and keep the pip prep for the entry, right? And this makes some pip prep go to the next, right? So this is some hard part for the double pointer, right? So when the double pointer holding the value, this pointing the actual the value of the this pointer, right? This pointing value, right? So without this, right? This hold the pointer value for this, but this holding the value from the some p prep, some pointing, right? So this will be changed this pointing value, right, to the next. So if the next is exist, the next pp prep would be pp prep, right? So we can review in perspective of the real use case for this. So this n will be selected from this entry, right? So n will pop up from this, and n would be filled with the meaningless value for the debugging. Right, so static inline void h list del on the init struct h list on the node with n. So if n grab on the h list del n init h list, right? This is same flow previously on the list implementation, right? And static inline void h list add head struct h list node star n struct h list head after n struct hlist node first core h first, right? And next be first if first prep it and next, right? Typo, sorry. And h first n and prep h first, right? So this makes some list head, h list head, right? This typo, right? H list head is the manager for this data structure, and we can extract from the hlist node from the hlist head, right? hlist head only have the hlist node pointer, one pointer, right? So this pointing the first, right? And we can get the first element from the this hlist, and we can change and next, right? The first, right? So you can see the whole bunch of the hlist head have pointing the first element for this, and new hlist node are put in here and next pointing the first, right? So if first pp prep would be and next is address, right? So pp prep have some, how do I say, previous pointer, right? So this makes new entry to pointing the first, right? And right, and next, right, pp prep, right, make some first element pp prep go to the right. Hard to say, right? Very complex with the pp privacy existence, right? H is first, right? H is right. H is in here, right? This typo, right? H is first going to the N, right? And pp prep will be the H is first, right? So I need to find a picture from this. This is hard to understand. All right, thank you. Right, I review this H list a few times, but I need to review again. When I view the real image, I can understand what it means. Very sad. Right. Right. You can see. Right. There's so many diagrams for this. Right. This is the real implementation view of this, right? So pointing is directly from the next, but this is the tricky, right? PP prep pointing the next, right? So this code say about this. Add head if, right? This is the alright. We can see this is the table of this, but you can see some h list head is the some element for this hash table, right? So the first are pointing the h list nodes, right? And right, these steps are easily understand and check the first, and we can see this code first pp prep, right? In this time, first pp prep is here, right? And next, right? And next, right? And is new, right? New node, h list on the node, right? So pp prep, first pp prep, go to and next, right? pp prep must pointing next member, right? This is very important, right? First, right? And next are changed with the first, but the first are preserved in this stage, right? So first, is pp prep, is pp prep must there will be new element in here, right? So this must pointing the ends next, right? Very fun, right? So H is first, right? Writing, right? Laney, and right, there's some score in this region, right? So H first, right? H first, right? We keep in this step, we keep, but we change it, the new H list node, right? And pp prep are changed for the first prep and next, right? Right, very tricky, right? We need to remember pp prep pointing the next member, not the H list node, right? This is very tricky, right? So with this, the new element will be added. In perspective of this diagram, pp prep pointing the first, and first we're pointing the this. So we can we can find the next member with the pp prep, right? Right. And as you can see, when the uh, H list head are tons of the H list head in there, this makes some efficient for this, right? So we can uh, find the each element with this structure with the next and pre prep, and this will save the 1 point member in comparison to the linked list, a circular doubly linked list in the Linux kernel implementation, right? So, right, I think uh, I I can more easily explanation for the next time, but I forget about it again and again. Right, this is very tricky. Right, right. PP prep doesn't seem intuitive, right? Right. This is, I think this is some Linux kernel GRU implementation perspective, right? Right. I think most of the other OS are not implemented something like this in modern day, right? It's very tricky, but fun. So, right, we add some API for this inline void hlist add before struct hlist node star n struct hlist node with next and pp prep, right, next pp prep and next right, next pp prep and right, next and star and pp prep and right. Right. So if we know that this target, right, we can add before the new in this next, right? So next is pp prep, right? pp prep pointing the next member, right? So we changed it and ends next will be next, right? We add before the next, right? And next pp prep, right? The ends next, right? Most pointing, right? The next member in the previous. But the pointer is double pointer, so we add, right? Tricky, very tricky. So inline void hlist add after struct hlist node star n struct hlist node next next and next and next right, next prep and next if next prep next wow, I will skip this explanation for this time. Right. tons of tricky. H list entry, PTR type and member, container of PTR type member, and define H list for each post head, right? And for post head first post, right? It makes reduce my typo. Next. Right. Oh, this another group part, right? 4, 1, oh, right. I need to find what this meaning on this, right? Prefetch 1. Wow, what is meaning? Right, and right. Good. This the two part of the first part is in here, and condition for the for loop in here, pause and prefetch pause next. And what about this? All right. And pause next. Right. Very clever. Right. Okay. Okay. Great. And also there is some safe implementation for this. So each safe pause and head, right? For pause head first, pause and pause next. Right, and pause next, and 1, pause for n. Right, clever, good, right? So I think it would be last of the implementing in the list.h if possible, right? I will implementing end of this part with the HashMap based on the Linux kernel-style circular doubly linked list implementation. So H list for each entry, iterate over list of given type. So TPOs the type start to use as a loop counter and pause the struct hlist node to use as a loop counter. Head, the head for your list, right? And remember the name of the HList node within the struct, right? Good. And define HList for each entry. TPOs, pose, head, and member. And for pose, head, first, right? And pose, prefetch, pose, next, right? And one, great. And wow, there is another condition. So I need to enter in this position, right? So long. TP was HList entry pills type of star TPOs member, right? So entry, right? Entry and end of the bracket and one, right? So I need to add this in here. And last, the iterating index are pause, next. Good, right? Clever, and good, clever, right? Right, very wrong for this, but we need to add this API for the iterating the element on the H list. Right, we saw this. And we gonna HashMap implementation. Woo! Last statement will be the value of the entire. Oh, good, right? Right. I saw this case. Right. So bracket makes true, right? The last element, last value is one, right? Great. So we gonna implementing the hash map, right? I think HashMap implementation like things are not occurred in the Venus kernel, right? But this user space friendly and not the C part file, not yet, right? I will list.h, right? List.h have all the information for this. So right, I will add this. Good to go. Oh, I add this in here, right? Include std-def.h. Same way in the list implementation, include stdio.h, stdlib.h, right? And we made a hash node. Node structure to be stored in the HashMap. Key string value integer. Struct hash node, right? Char key, right? Int value. I think bar is enough, right? So struct hlist node, right? H node for this, right? Good. And struct hash map, struct hlist head bucket, and unsigned int size, right? Good. And we need hash function for the shuffling, right? So this is some DJB2 hash function from the some mathematician, right? Static unsigned, right? Static unsigned long hashy, right? I think this will be enough hash, right? But I edit const char str unsigned long hash. I saw that this is the very important number for the some mathematical reason, right? C str proper so hash right. Also, this is the very important part for this hash function, right? These functions are mathematically proven for their performance and effectiveness, right? So return, right? I need return hash for this. Good. And we need some operation function, right? So create and initialize HashMap. So first parameter is size, right? Bucket size. Return pointer to create HashMap. Null on failure. Good. So struct HashMap create and right. I need to upper this unsigned, right? Always typo in this keyword inside. Great. Right. I think this is Java style, right? I need to enter this function. So, right. If size empty, discard code, return null value for this time, and struct hash the map. I think this would be great for this time. Right? Doesn't mean in the map struct HashMap pointer typecasting from the malloc size of struct HashMap. Right? If not map, this is very familiar coding pattern, right? Here malloc HashMap failed. Okay, don't need to. Right. And return right. Great, clear. And map bucket struct hlist head star for this malloc size of struct hlist head right size of this slot of size of this, and there's typo, right? No problem for this. All right. Good. If map bucket error malloc bucket failed. Woohoo. And also we need to free map in previous allocation, right? So return null. Good. And right, we can initialize our hlist finally. Map size, right? Size for I think unsigned right, unsigned int, right? Unsigned int I equals 0, I size I, and we don't need to add a bracket. hlist head at map bucket I. Whew. Right. Init hlist head map bucket I. Right. And return map for this. Whew. Very long time. And right. There's bunch of function for this. Right. We make some HashMap crate for this and continue it for search for node using key internal helper function and at param map hash map pointer second param would be key, right? Key to search, return found hash node pointer null if not found. Great. Static struct hash node pointer hash map lookup struct hash map star map const char star key, right? And enter. Right, unsigned signed long hash hash the function key unsigned int index hash percent map size struct hlist head map bucket index struct hlist node pos struct hash node entry, right? Good. Right. And right, I think we don't need to, right? Okay, understand. Hlist for each entry pause add h the node, right? Entry is important, but I didn't add a bracket for this JMP entry key, right? Key, right? Match, right? So this case return entry, right? Good, simple. And return other case returner, right? Simple, not too wrong, right? Retrieve value using key param map HashMap pointer second param key to search and third param value, right? I need to tap more pointer to store the value, right? and return value 1 if right? 1 if key found, 0 on failure, right? Good to go. And int hash map get struct hash map with the map and const char star key and int bar, right? So struct hash node star node hash map lookup map key. If node exists, then right the value would node, right? No value, right? I want to use val, right? Val, right? Return 0, right? Right. There's some other function need, right? So, but I need to check out the value. Good. And insert key value pair. Updated value. Already 있지. param map HashMap pointer param key to start, the key to insert, right? Insert and param value, right? Value to insert, right? But I want to use bar, right? And return 0 on success, -1 on failure, memcation error. Right. Good to go. And int HashMap insert struct hash map star map and const char star key and int bar struct hash node star entry and hash map lookup map key if entry entry bar, right? Return 0. Right. We can easily look up with the other function called HashMap lookup, right? And entry struct hash node pointer malloc size of struct hash node, right? If doesn't found entry, good. So p error malloc hash node failed, right? And return -1. Entry key, right? I think this more than, right, in a man, right? And right malloc and we can copy key string and set value, right? So str the key if not entry key then p error str the failed, free entry and return, right? Entry value, not the value, right? Right, and init h list under the node at entry h node unsigned long hash function key, right? Unsigned map size, right? Struct h list head star head map bucket h list head at entry h on the node and head, right? So return 0 in this case, right? Whew. And we can add elect node using key and at param map hash map pointer param key to delete again, right? So void hash map delete struct hash the map with pointer const char star key. So struct hash node star entry are looking for HashMap lookup map dash key. If entry h list del add entry h node, right? And free entry key free entry, right? Whew. Clear. And we go to HashMap print. Void HashMap print struct HashMap map. Right. Only two remain. Cheer up. Cheer up. Right. So we can add some beautify HashMap content bucket size different hue. Okay, good. And we add map size, right? Int nt 0. I think this is great for this time, right? And for on int I equals 0, and no, I equal 0 I until map size and I increased, right? And struct h lift head, right? So head map bucket I if h list empty head printf bucket I, right? And struct I think can offer this variable struct h list node pos struct hash node star entry, right? So H list for each entry, pause, add H number node. Good. So printf right, good. And that's D entry key and entry bar, right? So count shanty edit, whew, right? And printf right. Then for this and right, we write this loop and if cnt and like this, printf map is empty. Printf total element and d whew, great. So last function remain void, right, for the selection purpose. So destroy HashMap and free all memory. Get param map HashMap pointer and void HashMap destroy struct HashMap star map, right? In this case, no map. You can return to nothing. Printf to string HashMap. So int cnt so for unsigned int I equals 0, I map size I plus plus struct h list head star head map bucket struct h list node, pause, and end, right? Struct, start entry. Whew, almost ended, right? Sure, let's go. HShift for each entry, save, entry, pause, and head H on the node. Right. So we can look for H list their entry H on the node. Right. Free entry key, free entry, and the NT++ for this. So when ended, map bucket free map printf free the element TNT, right? Cool, right? Woo. So we can write up the HashMap function in the main code, right? We are prepared for this. Whew. Right. I'm so hope this time. HashMap.c and include std def.h include stdio.h include stdlib.h include string.h, right? Sharp include list.h. I think we can clean up the header file, but I'm moving on this time for this implementation, right? So struct hash of a map pointer map with hash map create, right? This time we create with bucket size with 16, right? So if doesn't allocate it, return 1, right? And we inserting the data, right? No need to, right? Hash map, hash map, insert the map, list 25, hash map. I think we can use this time, right? Right, so Bob 13 Charlie 5 and David 20 and right. So hash map print map, right? It would be print all the things in here and printf. No, right. I think this is sufficient for this time. Hash map insert with map list 26, right? Hash map print map. So find int bar and if hash map get map for the pop. I think Linus could Linus, right? Bar oh, you need to bracket printf found the bear, right? And else Linus not found, right? Cool. And if hash map get map Georgie with bar, right? Right. We add this simply as right, and we can add this the left hash to a map select map Charlie, right? So we can check up this to print, and also you can once more if, right? And finally we can destroy our map in this example, right? So I need to compile hashmap.c with -o hashmap, right? So I think, oh, ah, profile string, right? Oh, H list for entry safe, H list for each entry, right? Mm-hmm. So I need to add this in a mem, right? Oh, bunch of error, right? Typo, right? First undeclared, first, right? Int, I think, no, adding here. Thank you, Yansu. I think uh, coding with the YouTube live streaming, this make this like some Red Bull, right? Actually, I'm sleepy when I ended up the list implementation, but when I go to the HashMap, I wake up my mentor, right? So, what is the H list for safe, right? H list for safe, right? I can simply each entry for each entry safe. I can add this like this, right? So, and there is some other error. Some right, list for each entry safe contains some incompatible pointer. This makes some bunch of error from this. Ah, right. Hash node, right? Hash, no, right? and no member, right? Mem under undeclared. I need to find it. Right. To go and right and websites in here. Right, I need to touch them in Hessian websites. Right. And right. It's not place. Right. And clear. Right. Mem. No map in the member. Right. Oh, right. HashMap. Map has buckets. Right. Right. I think this is the main issue. Right. Clear. And this. And another error. Static inline int before. Right. Right. Good. Unhashed int. Right. Is there any problem for this code? Right. Right. I see. I omit this. Right. Clear. Go again. And right. Init hrest has no member. Hrest node. Right. PPRV. Alright. PPRV. P trap. Right. No. Clear. And right. Alright, structure. Struct, right. Clear. Feast. Wow. Very funny. Right. I first Right, clear. Compile again. Right. Struct HashMap. Incompatible type assigning to HashMap from HashMap star. Mhm. I think I omit the star in here. Right. Map. Right. Star. Clear. Right. Inner mem. Right. Inner mem. In the H. Error no. Right. Not error the H. Error no. Right. Finally, we can compile all of these things. Whew. Right. This time is the worst that I'm over the 2 hours of the live streaming. But I think this is very meaningful because I didn't write live coding while doing the live streaming, and um, this is the wannabe point that I want to be some explanation with the low level system programming. So I think this day is very meaningful in my life. Thank you, all of the folks, right? So I can doing this, right? So right, there's some format problem, but I think uh, we made some 16 bucket size, and there is some if David Ellis in here, and like total 3 elements, and add like this, right? Linus and George not found. Why? Right. I think there is bug from this program. Alice, if David, Alice, right? Total 4 elements. Right. So when I lastly tested it with the right, I think program should be look like this, right? So Bob would be found, it's really not found, right? Exactly, right? So I need to debugging it. So I think header is not problem, my guess, but I think some missing point in my HashMap implementation. Or so I think this is not the problem for this, right? I think maybe a problem for H, right? Right. That list. I think there is some problem for these things. right? First of all, right, hash function. I review the hash function this time. Plus C. I think it is not the happen in this and map create. I think there is no problem for this, right? Map size I0 I less than size I plus plus bucket size map, right? And HashMap lookup key hash function, right? Hash percent this hat index pause entry add each node -mp, right? Entry no problem. And get hash node lookup from this and get bar from here, right? Right. I found it. I missing this, right? And there is right 0 and name and entry bar h node init h function map size bucket index, right? There's no problem from here. And right, h node free entry key entry I0, right? Think there's no problem in here, but I need to more beautify this code, right? I omit the arrow in here and print, right? Ner and this, right? And I'm compile again. I'm curious about that, right? 3 elements, but the bucket a 0 for this time. Why? Right. I added this 8 element from this, so I need to review the print in here. Why? Why map size is that? Okay, and CNT is okay, right? And not H list empty, right? And head map bucket in here, and right Right. No need to initialize it here. I size until the size. Right. Printf bucket u I s t. Right. And no problem. From my view. Right. HashMap and HashMap. Right. VIMDF. No. I need to compare the header. Right? No problem for this, I guess. And hash size, right? Similar. Right? Makes sense. Was head, but no difference from this point. Mhm. Value not bar, right? Return 1 minus 1 star index hash. There's no big difference in this code, right? Free memory, like the same. Entry key, entry bar, right? There's no obvious difference. Almost same, right? Total element. Right? So I copy and right? Mm-hmm. Linus Georgina found right. I think there is some difference in the head, I guess. Right? So I will find the difference in this code, and I will share it. So my plan was studying the LRU cache, but I think this is almost over 4 hours. So I think this is the time to end now. So thank you everybody the for the interest in the low level system data structure programming. So I hope you were. Goodbye, every folks. Have a great day.